back and forth between discussing Roxwell 4.7 solving equations and actually doing the book work. If you after test 5 you were not making at least a 70, I had already emailed you and let you know that you need to, or should take the alternate final, which would allow you to, if you pass it, would allow you to be a TSI complete, even if you don't pass the whole course. So if you haven't heard from me on that, that means that you're passing the intermediate portion of this course, and your grade can only, for that part, can only go up. But if you're not passing, there's still, I mean, you still have hope, but if you want to make, you know, I think it's a good idea to bet on the alternate final. And I'll be sending y'all some emails to tell you how we're going to prepare for that. So, all right. So let's go ahead and do the Kahoot. Again, it's short. And try to get on if you can. If you absolutely can't get on, then again, follow along like always. But if you are on, it's always worth extra credit on the homework. I'm going to go ahead and start. If anyone can jump in after we started, that's fine too.
About to say the people that are left in this class are doing pretty good, but then like they did not come today. But the ones here are doing pretty good so far, I think, for the most part. Pretty strong group.
It is. I mean, the people that are hanging in good.
My other class is about to have their withdrawal date.
What?
My other class is about to have their withdrawal date on the 19th.
Okay, so most of y'all got that right. Good. So if you have a rational function, the denominator is what you're concerned about with respect to the domain usually. So you are going to take that denominator and set it equal to 0. And whatever that solves to, so you get x equals -4, that is what is not included in the domain. So the domain of this function is every single number in the world except for -4. Vertical and horizontal asymptotes. Okay, so let's look at this. So good. I'm so happy all of y'all got the no horizontal. This maybe was a little tricky, but you saw that there was no horizontal asymptote because the degree in the numerator is larger than the degree in the denominator. That's awesome. The numerator will factor to be x minus 8 times x plus 4 over x plus 4. And those x plus 4s will cancel. So that means that there is no vertical asymptote at all. That would be a hole. And that's it. It's just going to be a line, x minus 8 with a hole in it. So there is no vertical, there is no horizontal asymptote on that one.
Do we have any of the like 1 over x squared graphing stuff in the homework yesterday?
No.
Because it was in the written homework, and I don't think I went over it.
The 1 over x squared was? And 1 over x?
Yeah, with the graph shifts and.
Oh.
Yeah, it was in there.
Yeah, and that's not on the test. But yeah, we probably should talk about it.
Yeah, I mean, if that's what was confusing them, or if they didn't get that turned in, I mean, they can probably still turn that in, right? I think we still. Pretty sure Blackboard still allows late submissions.
Yeah, and if they sometimes if it's too late, it won't. But then you can always go in and replace their 0. So I do that.
Because I remember doing it, and in the notes, but we didn't do it in the book work.
Yeah.
But then it showed up again on their written work. So
It's weird how how that is. Okay, so on this one, most of y'all got this, but let's just talk about it anyway. So I'm gonna change this to, I just went ahead and simplified the first fraction. And then I'm gonna multiply by the reciprocal of the second fraction. Okay, so that's x over 2y. And then this is 2x to the 5th y over 3. And then we can cancel the y's and the 2's. And when we multiply, we add the exponent. So that's going to be x to the 6th over 3. So I know myself, these start getting so messy that sometimes I'll drop a variable. That's the main thing I have to watch out for. Okay. So let's look at this one. So the common denominator is x plus 2 times x minus 1, because you take each denominator, and that's your LCD. So what this fraction is missing is the x minus 1. So you have to multiply top and bottom by x minus 1. What this fraction is missing is the x plus 2. So you have to multiply both the numerator and the denominator by the x plus 2. Then if you multiply these fractions out, if you just use the distributive property or FOIL on this numerator, you get 3x squared minus 4x plus 1. And this just turns out to be x squared minus 4. And so 3x squared minus 1x squared would be 2x squared. And then you've got your negative 4x. And then 1 minus negative 4 would be plus 5. So don't forget, you have to get a common denominator. You can't just add or subtract straight across the board. And multiplication and division, it's top times top, bottom times bottom. But when you're doing addition and subtraction, you have to get a common denominator. We did do ones like these in yesterday's bookwork.
Oh yeah, finding asymptotes and graphing from the asymptotes. I guess it probably could have done that on those if I thought about it.
Yeah, maybe that's why we. Yay. Okay, so yeah, this one, you know, you have horizontal asymptote of just 1, because the degrees are the same in the numerator and the denominator. So y equals 1 is your horizontal asymptote, and then x equals 2 is your vertical asymptote. This is the only one that would make sense.
But I think one of them was like 1 over x plus 5. So like, it's easier maybe to think of that as a graph transformation.
Oh, maybe.
Yeah, you'd have to convert it and find the asymptote, and it would be a bit of work to do it the other way.
Uh-huh.
It's just, but it is possible. They are one and the same thing.
Right, good job, guys. All right. So now, okay, we are going to go back to so first of all, go over a couple of reminder type of problems for lesson 4.7. So if you have, you can always multiply through by the lowest common denominator, always, always. But if you have a single fraction equal to a single fraction, then multiplying through by the lowest common denominator is really exactly the same thing as doing a cross product. So if you have something like this, this is like 5x over x minus 3 equals negative 10 over 1. And you see you have one rational expression equal to exactly one rational expression, so that you've got a ratio going on here. So we are going to do a cross product So 5x times 1 is 5x. And then negative 10 times x minus 3. So this would be 5x equals to negative 10x plus 30. And then you add 10x to both sides, and we get 15x equals to 30. And so x would equal to 2 if you divide both sides by 15. Then you need to check, the main thing you need to check is, would that give you a 0 in the denominator? Because the domain would be of this first rational expression would be x cannot equal to 3. Well, 2 is not equal to 3, so we're in good shape. It's always a good idea to check your work anyway. So if you said, does 5 times 2 over 2 minus 3 equal to negative 10? And it does. You don't have to show me your check, but I know that I have caught myself many, many times having made careless error and catching myself because I checked it. Now, this won't work if you have something equal to 0. So normally if I have something equal to 0, I make sure that this side is completely simplified so that, or factored, so that if there are any common factors, then they would go away. But there's not in this case, and there usually is not, the ones I've seen anyway on the book. So what you have to remember is you can never have a 0 in your denominator. If you do, it's just not copacetic. So all you have to do when this happens is worry about your numerator. So you would just say x plus 7 equals to 0. So x would equal to negative 7. So anytime you have a rational expression equal to 0, make sure it's simplified and then just worry about the numerator. Okay, so now let's do the bookwork. The 3 problems in the bookwork that are set up like this are 1, 7, and 25. So I want everyone to do bookwork number 1, 7, and 25. And in a few minutes, we'll discuss these together. So, and if I'd love to have people volunteer to do a problem. So if you'd be willing to do that, that would be great. So everyone spend a few minutes doing these 3 problems. And these 3 you can either do by using cross product or finding the lowest common denominator and multiplying through by the lowest common denominator, whichever one you prefer.
Ms. Walton?
Yes,
If it's all right, I'd like to take a shot at number 1 when everyone's ready.
please. That would be great. Is that Timothy? So when everyone's finished, yes, if you'll do number 1, that would be perfect.
Awesome. Thank you.
Thank you. Anyone want to volunteer to do number 2?
I don't think we talked about the fundamental theorem of algebra. I think we skipped over it.
Do what now?
The fundamental theorem of algebra.
Oh, we haven't.
Yeah, I think because I thought it came after the division, but I don't think. I think it comes before it now that I think about it. I don't know. I can't remember. Because I think we have to have division to get the factors out. That's what I was.
Uh-huh.
See. Yep, comes in 4.5.
Okay, so we should have covered it, right? But we didn't do 4.5.
Yeah, they kicked it out.
Great.
I can talk about it tomorrow if you want.
Okay, that'd be good. Okay, let's go ahead. Timothy, would you walk us through number 1?
Sure. Okay. Give this one a shot. So 2x over x plus 2 equals 6. So we're going to cross multiply by 6 over 1. And after you multiply, I rewrote the equation to 2x equals 6 parentheses x plus 2. And then
Okay.
all right, and then we'll distribute the 6. It becomes 6x plus 12. All right, sorry. And then I subtracted 6x from both sides. And 4x equals 12. And I divided the 4 into the 12. And I got x equals -3.
Beautiful. Okay. So then we can see that -3 will not give us a 0 denominator. That's we really need to check for that, because that does happen sometimes. And if it happens, and then you just need to throw it out and say there's no solution. This would be called an extraneous root. So if we want to check it fully, yes, so it's 2 times -3 over -3 plus 2 equal to 6. And it does. Can someone walk me through number 7, please?
Would you have
Aurora,
to change the numerator?
Elliot,
Would you have to change the numerator?
yeah, okay, so the numerators, remember, if it's set equal to 0, The numerator is all we have to worry about as long as it's simplified, right?
Yeah,
So what
because
would
like
you
I don't see no point in simplifying it right now.
No,
since
you
it's-
can't. That's as far as, I mean, this is fully reduced. You can't do anything more with it. So then what would you do?
You would worry about the top one and do x plus 1 equals 0.
That's right. So what's your solution here?
X equals -1.
That's right. That's it. And then, of course, if you check it, does -1 plus 1 over -1 minus 5 equal to 0? And that 0 over anything does equal to 0. Okay, 25. Hunter, did you get that one?
I got some answers, but I don't think they're right.
What did you get? They're probably right.
Wrong answers are the
Okay.
best ones, though.
Okay, so I tried it 2 different ways. I
Okay,
tried
good.
not factoring, and I
Uh-huh.
tried factoring
Okay.
the expressions first.
Which did you like better?
The one where I did not factor them before cross multiplying.
Okay. So go ahead and do it that way then, and then we can talk about the other way as well. So tell me what to do.
Okay, so the cross multiplication gets you 4x squared minus 36 equals x squared minus 3x.
Okay.
And then you subtract the 1x squared from the right side and the left side, gives you 3x squared minus 36 equals -3x. And then I added the 3x over, set it equal to 0. And then I solved by taking out a GCF and then factoring that
Great.
equation.
Right. If you can see to take out that GCF, that's really going to help you, right? So. And then.
It should be -12.
Oh, you're right. Thank you.
And then the factors for that are -3 and +4.
Yep, that was good.
And then the answers are x equals 3 and x equals -4.
Okay, good.
So that sets it equal to 0. So that means that's as far as I got.
Okay, it's great. All right, so now let's go back in and see what happens if you put 3 in here. What would happen?
The denominator will equal 0.
The denominator will equal 0, right? And you can't, that can't be, because that's not in a domain. Does everyone see why that 3 has to be scratched out?
Can you
Because if
explain
we-
again why it has to be scratched out?
Yeah, so if you take that 3 and you put it in the denominator, what is 3 squared minus 3 times 3? What's that going to give you?
0.
So if you plug that in to either one of these denominators, it's going to give you a 0, and you cannot have a 0 denominator. It's not defined. So that's why you have to throw out 3. And that's why it's really important that you check your answers. And then -4 would be okay. You might want to check it just to make sure that it actually works. So if we said 4 over -4 squared, which is 16, minus 3 times -4, which would be plus 12, does that equal to 1 over 16 minus 9? And that would give us 4 over 28. Does that equal to 1 over 7? And it does. So check. So the main thing, I would recommend that you check it all the way through, but the main thing you really want to make sure is that the answer does not give you a 0 denominator. And if it does, you have to throw it away.
Yeah, I don't know if you're particular about like wanting them to plug it in, but there's like kind of two ways to check it. One is if you like plug it in like that. The other is if you look at your domain restrictions. Our domain restrictions are going to be what, plus and minus 3 and 0, I think, right?
Right.
At those things.
Right. Yeah, exactly. So you could, I see what you're saying, Matt. Yeah. So you could just go, okay, right off the bat, my domain is x can't be 0, right? Because x times x minus 3. So x can't be 0 and x cannot be 3. And then x squared minus 9, that would be x squared. There's a couple ways you could do that. So x can't equal to plus or minus 3. So my domain is can't be 0, can't be 3, can't be negative 3. So that's another reason, another way that we would know to scratch out that 3.
Yeah, so if we got any three of those numbers, 0, 3, or negative 3 in our solutions, we would know to reject them.
Right.
Yeah.
Right.
So there's two.
Okay, so then this one also, just for grins, if you had, if you found the common denominator, this is x times x minus 3. This is x minus 3 times x plus 3. So the LCD is x times x minus 3 times x plus 3. So this one is missing the x plus 3. So I'd have to multiply the numerator and the denominator by the x plus 3. And this guy is missing the x. So I'd have to multiply the numerator and the denominator by x. So that would give me 4x plus 12. Well, actually, I'm not doing it the way I want to do it. If you multiply the whole thing through by the lowest common denominator, that's going to eliminate your denominators. So what's going to happen is you're going to wind up with 4x plus 12 equals to x. And then 3x is equal to negative 12. And x would equal to negative 4. So because we got rid of the denominators, which means we got rid of the quadratic part of the equation, we wind up with just that one root, which is a good one. Okay, so now if you have several rational expressions in an equation, then you have to multiply through by the lowest common denominator. So on this first little example, the lowest common denominator would be x squared. So if I multiply everything through by x squared, so I'm going to multiply every single thing by x squared. So here the x squareds would cancel out. And here I would get 3x squared over x plus x squared, because I have to distribute that through the whole second part. So I'm going to have 10 equals to 3x plus x squared. And then I need to set that equal to 0. So that's going to be x squared plus 3x minus 10 equals 0. And that will factor. I need two numbers that multiply to negative 10 and at the same time add back to 3, and that would be plus 5 and minus 2. And then I set those factors equal to 0 and I get x equals negative 5 or x equals 2. Now the only restriction in this problem is the domain is x cannot equal to 0. So both of these, if they check, will be fine. So like if we did negative 5, that would be 10 over 25. Does that equal to 3 over negative 5, which is a negative 3/5, plus 1, which is 5 over 5. 10 over 25 simplifies to 2 over 5, and negative 3 plus 5/5 plus 5/5 is 2/5, so it checks, and 2 will check as well. Now one like this, before we can do anything with it, we have to make sure that this is factored. And a big hint, almost always, because we're not going to want to make these just ridiculously messy, is that it will probably factor to be those two factors. So now I'm going to multiply everything through by the lowest common denominator. And I like the way Matt does this. So if you list all the denominators, x plus 2, x plus 3, and x plus 2, x plus 3, you can see that this one has everything we need, right? So that's the one we pick. And I'm going to multiply everything through by that, x plus 2, x plus 3. So that will give me, on this first one, if I multiply by 1, that gives me x plus 2 times x plus 3 over x plus 2. And if I multiply the second one, that gives me x plus 2 times x plus 3 over x plus 3 equals 2 times x plus 2 times x plus 3 over x plus 2 times x plus 3. So here the x plus 2's will cancel, here the x plus 3's, here everything. So what we are left with is x plus 3 plus x plus 2 equals to 2. So that's going to be 2x plus 5 equals to 2. So 2x is equal to negative 3, and x is equal to negative 3 halves. Okay, so the domain here, x can't equal to negative 2, and x cannot equal to negative 3. So negative 3 halves is fine as far as that goes. And if you want to check it, you can just use your calculator, or you can use, let's see here. I did it already. So I took the negative 3 halves and I put it in here. 1 over negative 3 halves plus 2 plus 1 over negative 3 halves plus 3 is equal to 2.6, repeating. And then I also put it into the second fraction, the second rational equation, 2 over negative 3 halves squared plus 5 times negative 3 halves plus 6, came up with the same thing. So I know I'm in good shape. All right, so now everyone work on number 11 and number 17. how you do on those. There were some problems that were listed in the assignment that we actually aren't doing because we're not doing variation problems. So the last, I think, 4 problems that were listed, you don't have to worry about those. All right, let's go ahead and look at these. So on number 11, what is the lowest common denominator? Anybody? Don't everybody talk at once.
Are you supposed to find the least common what's called least common denominator?
Yeah, lowest common denominator first, right? What is the lowest common denominator?
Isn't it x and then parentheses x plus 2?
That's it, exactly. So that's what we're going to multiply this whole equation, every single thing in this equation by that, right? So I have x times x plus 2 times 1 over x plus 2 plus x times x plus 2 times 1 over x equals 1 times x plus 2. So here, if I multiply these out, the x plus 2s are going to cancel, right? And I'm just going to be left with an x. If you're doing it right, the denominator should totally go away. Plus, here the x's will cancel, and I'm left with x plus 2. And here I'm left with x squared plus 2x. So this is 2x plus 2 equals x squared plus 2x. And if I subtract 2x from both sides, I wind up with x squared equals to 2. And then what would I do?
You would square root it?
Right. And don't forget plus or minus. So our solution would be x equals plus or minus the square root of 2. I check that. Yeah. Okay. So I didn't check both of them, but they both should work. If I check just the 1 squared of 2 right here, where is it? Right here. And you can see that 1 over root 2 plus 2 plus 1 over root 2 does equal to 1. And negative will also work. Okay, then number 17. What's the common denominator for number 17?
X and x2?
Okay, so
Or
between
could it
x,
just be x2?
yeah, x squared, right?
Okay. Yeah, my bad. X squared.
Yeah, no, that's okay. I know what you're talking about. All right, so I'm going to multiply every single one of these terms by x squared. And here the x squareds will cancel out. So I'm left with just 35. And here x squared divided by x is just x. So that's 4x plus 15x squared. So this is 15x squared plus 4x minus 35 equals to 0. Now you can use the AC method if you want. Or, because I'm not wanting to spend too much time on this, I'm going to just use guess and check method. Usually if you're using guess and check, you want two numbers that are going to multiply to 15. So I would pick 5x and 3x. And then I need two numbers that are going to also multiply to 35 in the end. So I'm going to pick 7 and 5. So that would give me 21x, and that would give me 25x. And in order to make that work, the 25 would have to be positive, and the 21 would have to be negative. So we have factored it. You could, of course, use the AC method. It just takes a little longer. So then we're going to set those factors equal to 0. And I will get 5x equals -7. So x equals to -7 over 5. And then here 3x equals to 5. So x equals to 5/3. What did I do? I do something. That'd be plus 21. Oops, I did. The plus 25. This should be plus. This should be minus. Sorry, guys. Right? So this should be positive, and this should be negative. So if you wanted to check it, go to Desmos or use your graphing calculator or whatever. If you put in 7/5 on the first side, you would get 35 over 7/5 squared, which is 17 point blah, blah, blah. And if you plugged it into the second side, you would get exactly the same thing. And then if you plug -5/3 in, it would also work. Okay. So the last problem on here is the word problem. It's not too bad. Okay. So on this last one, this is so weird. Something is interfering with my. Okay, there we go. So it says the grade X of a hill is a measure of its steepness. For example, if a road rises 10 feet for every 100 feet, so here we have this road is rising every time you go 100 feet, it rises 10 feet. That would be 10% because 10 divided by 100 is 10%. So then it says the braking distance for a car traveling at 50 miles per hour on a wet uphill grade is given by, this is hard to see, so I'm going to rewrite it, d of x equals to 2,500 over 30 times 0.3 plus x. That's the formula, where x is the grade. So it says that evaluate d of 0.05 and interpret the results. So what would we do? How would we do that?
Replace the x with 0.05.
Right. So we're just going to say d of 0.05 is equal to 2,500 divided by 30 times 0.3 plus 0.05. Everyone, if you come up with the same thing I do when I do this one. Anyone get it yet? So when I plugged that into my calculator, I got 238. Do y'all agree with that? Anyone disagree with that?
Which one did you get again?
I got 238.
Okay, yeah, I got that too.
Okay, good. And what does that mean? What is the grade of the hill?
Is it miles per hour?
So they're telling you that X is the grade of the hill. So if 0.05 is our X, right? So what is the grade? What steepness is the hill as a percent?
5%.
Right, right. So when the grade is 5%, what's the stopping distance? Because remember, this formula figures out stopping distance for us.
238 feet.
Right. Okay, now the question B says, describe what happens to the braking distance as the hill becomes steeper. So we really didn't have to do B. So let's just kind of talk about it. As the hill becomes steeper, what's going to happen to the stopping distance of your car? Will it be less feet or more feet? What do you think?
It'll get shorter.
Right, right. If you're driving on a hill and you're going a very steep hill, when you brake, it's going to take less feet to stop than if you're going on a flat surface or when it's going down. So the more steep your grade gets, like if it goes from 5% to 10% to 20%, the shorter your stopping distance will be. Okay. So then it says estimate the grade when the braking distance is 220 feet. Okay, so first of all, will the grade be greater or less than 5%?
Less than?
Right. Well, wait, wait, think about this. It takes you less footage to stop
More than, thinking
So it's
backwards.
gonna be, right, so your grade will be steeper, right? So it's gonna be, so we know right off the bat that the grade will be more than 5% since 220 feet is less than 238 feet. Okay, so I'm going to approximate this. So I'm going to say 2,500, and they're saying estimate. Okay, so 2,500 divided by 30 times 0.3 plus some x, because we're trying to find out the grade, which is our x, is equal to 220. Okay, so I can divide this 2,500 divided by 30, but since it says estimate, I'm not going to be exactly precise, but I'm going to say 2,500 divided by 30 is about 83. Actually 83 and a third, but they're saying estimate, so I'm just going to leave it 83 over 0.3 plus x equals to 220 over 1. And now how could I solve for x at this point? What would be a good way to solve for x?
Cross multiply.
I would cross multiply. I like to call it a cross product, but yes, that's what it is. Or we could multiply through by the lowest common denominator. Really, it's the same thing. It's going to get us our same answer. So I'm going to say 220 times 0.3 plus x.
Call them butterflies.
Equals 83. And if I distribute that 220, give me 66 plus 220x equals 83. So 220x is going to be 83 minus 66, 17. Divide both sides by 220. And that would give me 0.077, etc. So what would the grade be approximately in percentage speak?
$7.7.
It would just be, yeah, it's going to be, well, you could put 7.7 or approximately 8%. I'd take either one. Yeah, anything close to that. And does that make sense? We knew the grade was going to be more than 5%. So that makes pretty good sense to me. Okay, are there any questions? Because we are really through for the day. I'll hang on if anyone wants to ask any questions about last night's homework or anything about today's homework also. And then tomorrow, we're just gonna kind of stop and review everything we've done so far.
Yeah, we're multiplying, dividing, adding, subtracting. What else? The graphical
The whole caboodle.
Are we going to continue this worksheet?
No, you don't have to finish. You mean the book work? Is that what you're asking me? There were several problems on the book work that you don't have to do. I think there are 4 at the end that is material we no longer cover in this class.
That.
If that's what you're asking me.
What did they draw? What did it involve? I was wondering.
It was inverse variation.
Oh, so we just ignored those 4 and then just
Yes,
do the
yeah.
homework. Okay, sweet. Thank you.
Yes, sir. Y'all have a great day. And again, if you want to hang on for a little while, I'll be glad to